Hello, I'm happy to be here with you again, and I need you and really need you to pay attention to this explanation because even though this is a topic that you study in some chapters before, it's very important that you understand the new concepts. So please pay attention to this new explanation. We are going to work in finding the gradient of a curve. First of all, what is a gradient? If we go back to the book on chapter number 10, we will understand that the gradient is the line that tells you how steep the line is. So, to find the gradient of a curve, as I told you, we need to understand what is a gradient. This concept is basically how much the line moves up or down when we move 1 unit to the right. That means that if I move 1 unit, I'll check the distance that the line moved up or down. We understand that when the two lines or two curves are parallel, they will have the same gradient. Okay, so in here we have this simple graph, and we see that we have different gradients, right? In this one, for example, or in here, or right here, each part of this graph has a different gradient. So, how can we find the gradient? Some parts of the trail have a steep positive gradient. Some others have a gradual positive gradient. Some parts are level and other parts have a negative gradient. It should be clear for you in this moment that a curved graph never ever has a single gradient like a straight line has. You cannot find the gradient of a whole curve, but you can find the gradient of a point on the curve by drawing a tangent to it. What can you understand from here? This part of the curve won't have the same gradient as this part of the curve. So, we cannot calculate all the gradient from this curve. So we have to make it by parts. The gradient of a curve at a point is the gradient of the tangent to the curve at that point. As I told you, only one point. Once you have drawn the tangent to a curve, you can work out the gradient of the tangent just as you would for a straight line. So we just need to choose which gradient we have to calculate, which gradient are we taking into account for our study, and we will try to find it out. So in this case, the gradient is equal to y change as x increase. What I told you, we move 1 unit to x and we check the change that y had. So in this case, with this formula, we have this graph, for example, and we want to see what is the gradient in this specific point right here. So what we do is that we make a line, a tangent, and as I told you, we see that this line BC is tangent to that curve in that point. So how can we draw the tangent? So first of all, mark the point that you want to check its gradient, and mark it with a dot. Later you place a ruler and you try to only touch your point, that dot that you just did, and later make the line so that the angle on either side of the point is more or less equal. Try to use a pencil. If you made a mistake, just you do it again. So how can we calculate the gradient having the tangent? First, you mark those 2 points, like P and Q, for example, the edge of the line in the tangent, and try to make the horizontal distance between P and Q a whole number of units. This means I already have this one. So I have P and Q. I'll try to make this line and this line as perfect as possible so I can make it fit into a whole number. When you draw that horizontal line through P and a vertical line through Q, you can form a right angle triangle called PNQ. Now to calculate the gradient of that curve, the gradient of the tangent PAQ, you will just measure the distance from N to Q divided by the distance from P to N. This is the theory. I know it's quite hard and complicated to understand, but we have that the difference between M and R is from 7 to 4 is -3, right? We go from 7 to 4. That means we go -3. Then the difference between Q and M is 3, as it goes from 2 to 5. Then -3 over 3 is -1. As you can see, here we have the -1, and here we have number 3. This dot in the curve has a positive gradient as it is going up. In the other hand, we have this dot on the curve, this one, and it's going down. So it's logic that the gradient at the point 1.4 is positive as it goes up, and the gradient at the point 3.6 is negative as it comes down. Guys, I hope you can understand this one. This is not an easy topic, I know, but I'm pretty sure that you are very smart and you can understand. Hope to see you the next time. Goodbye.